So now, if we have a look back at that create user method that we saw earlier on, you can recognize that all of this is simply a closure, and it's passed into this create user method as an input parameter. So this closure only gets called once the user creation has completed. And this is what we call a callback method. Now, to understand callbacks and completion handlers, we first have to go back to the basics, namely, how exactly does an app work? Now, previously we've talked about the anatomy of an app in the context of the model view controller, i.e. we have the model that deals with the data, we have the view that deals with what the user sees on screen, and we have the view controller that facilitates communication between the two. But this time I want to talk about the anatomy of an app, as in how it works behind the scenes, and what exactly happens when we click on a button or when we get some data from our database. So the way that it works is that we've got a button and we've got a view controller. Now, when we click on the button actually sends a message to the view controller telling it, hey, I got clicked. You need to update the view. You need to show something now. Show this image of a Bitcoin, for example. Now, in an app, you have many different components. You have videos that might have completed playing, you have buttons that might have gotten clicked, or you have data that might have been returned to you from the database. So the way that the view controller handles all of these events is by sending and receiving messages. So when the like button gets clicked, the view controller gets sent a message. Hey, this button was clicked, do something now. Or when you receive a phone call, then your operating system will say to the view controller of your app, like, hey, there's a phone call coming in, I'm going to need to shut you down. Or if you have a cloud-based database, as we do, then you might get messages from there as well. For example, I successfully created your user, here's their user ID. So essentially, a lot of messages are being passed around and received by your view controller. So we're writing code in anticipation of events. These events are messages that can be triggered by the operating system, or it could be from buttons, or it could be from third-party APIs. So let's consider these messages that we get sent from the operating system. We've all seen and used view.load quite a few times now, and we know it's the time point where our view is loading up. So we can get something to display on screen immediately when that view shows up. But did you know that there's actually a lot of other methods that are in the same family? And these together comprise of the app lifecycle. So when you consider your mobile phone, or an MP3 player, or your laptop, you have different amounts of memory in each of these devices. You also have varying levels of battery life. Now, for a device as small as an iPhone, your battery life is largely determined by the processes which the apps run. So the amount of memory that your app uses at any given time point is monitored by the operating system. And say if the user decides to navigate from your app where you're filling in a form to another app which is like a first-person shooter game that's really memory intensive, then your app might get assassinated by the operating system. So then your app has a life cycle, i.e. it lives and it dies. Firstly, your app gets launched, and then it becomes visible, i.e. it shows up on the screen, and then the app proceeds into the background. So this is when you click on your home button, or when you open up a new app, or when you get a call. Essentially, when your app disappears from the screen on your phone, it goes into the background. And in the background, it's held in memory until your app gets killed by the operating system. And that's because there's not enough resources to go around, i.e. there's not enough memory for everybody to run. So once something really memory intensive gets loaded up, then your app might get killed in order for those resources to be used by another app. So within your app, there's constantly messages being sent back and forth between different view controllers from the operating system to your own app or from third-party APIs. And when we're coding, we're essentially anticipating these messages and tapping into the time points when these events happen. And a completion handler or a callback is simply one of those events, is simply one of those messages that gets triggered once some process has completed. And once we get that callback message, then our app can continue and use some of the information that we've got as a part of the completion handler.